Qualitative analysis of organic compounds, test for sulfur or detection of sulfur. Okay, detection of sulfur by qualitative analysis method. First we have to prepare Lessines extract or sodium fusion extract. Sodium fusion extract. The preparation is we already discussed in our last session. Okay. During the preparation, if sulfur is present, sulfur gets converted into its ionic state or ionic form. Okay. 2Na plus S. During this fusion with the sodium, sulfur gets converted into its ionic form like this. Okay, so it gets converted into ionic. Now the reaction takes place in this ionic form of sulfur. Okay, first detection or first confirmation test is to a portion of the extract acidified with acetic acid. Acidified with acetic acid. First we have to acidified with acetic acid. And then add to this we have to add lead acetate solution. Lead acetate solution. A black precipitate of lead sulfide will be obtained. This shows that the sulfur is present in the organic compound. This is one of the detection for sulfur. Okay. The reaction is PbCH3COO twice. Okay. Reaction with the ionic state of sodium Na2S. Okay. It gets converted into, this is lead acetate. Gets converted into lead sulfide, which is a black precipitate. Okay. So it shows the presence of sulfur plus this is the first test. Okay. Next is to a portion of the extract we have to add sodium nitroprusside. Add sodium nitroprusside. A violet coloration is obtained which shows the presence of sulfur. Okay. To a portion of the extract we have to add sodium nitroprusside. Reaction is Na2S plus Na2FeCN 5 times NO. This is sodium nitroprusside. Okay, sodium nitroprusside. The compound obtained will be Na4FeCN 5 times NOS. This is violet in color. Okay. So this is another detection of sulfur. Now, if nitrogen is present, the reaction will take place in another manner. Okay. Because due to the presence of thiocyanate in this during the preparation of the sodium fusion extracts, nitrogen and sulfur gets converted into thiocyanate. Okay, that is Na plus C plus N plus S gets converted into NaSCN. Okay, so the ion will be SCN minus, thiocyanate ions. This will interfere the reaction. So first we have to decompose this thiocyanate into sulfide ions and cyanide ions. Then only we will get the usual test. For that, first we have to add excess of sodium. Added excess of sodium. So what will happen? The reaction will be like this. So NaCNS on reaction with excess of sodium, okay, it gets converted into NaCN and Na2CS. Okay, now the usual test can be done. So Na2S is there. We can do the usual test for the detection of sulfur. Okay. Next is detection of halogens. Detection of halogens. Okay. So first we have to prepare Lecine's extract or sodium fusion extract, and in this during the preparation of the extract, the halogens gets converted into their ionic state. Okay. So Na plus X is halogens. On heating, it gets converted into its ionic form NaX. Okay. Now we can do the different test. First test, to an extract, to a portion of the extract acidified with dilute nitric acid. We have to acidify the extract with dilute nitric acid. Okay, dilute nitric acid. And then we have to add AgNO3 solution or silver nitrate solution. Okay, silver nitrate solution is added. So different halogens gives different tests. Okay, different determinations. Okay, first chlorine gives a white precipitate. Gives white precipitate which is soluble in ammonium hydroxide. Okay, NH4OH, which is soluble in ammonium hydroxide. Bromine gives yellow precipitate which is sparingly soluble in ammonium hydroxide. Okay, sparingly soluble. Okay, in ammonium hydroxide. If iodine is present, forms yellow precipitate again, but it is insoluble in ammonium hydroxide. Okay, these are the different tests for halogens. Okay, but if nitrogen and sulfur are present, the complete reaction that will interfere these tests. Okay, so first we have to remove those ions. Cyanide ions and sulfide ions will be produced in the extract, so that will interfere the halogen test. So first we have to remove the reaction. So while we are adding silver nitrate solution, a black precipitate or a white precipitate will be obtained, so that will interfere the test for halogens. So first we have to remove that. For that, we to the extract or a portion of the extract is boiled with concentrated nitric acid. In such a case, okay, if it is boiled with concentrated nitric acid, what will happen? Cyanide ions and sulfide ions will decompose. Okay, and the precipitate HCN will be obtained in the case of NaCN. So that will with that extract we can do the test. Okay, so NaNO3 plus HCN will be obtained. Okay, Na2S sulfide ions on reaction with HNO3, it gets converted into plus H2S. Okay, this can be removed and we will get the usual test for the halogens. Okay. Next is detection of phosphorus. Detection of phosphorus. First, we have to heat the compound with an oxidizing agent like sodium peroxide or concentrated nitric acid. Okay, heated with an oxidizing agent. On adding this sodium peroxide, what will happen is this phosphorus present in the compound gets converted into sodium phosphate. Okay, so that is phosphorus gets oxidized to form phosphate. Okay, to the residue we have to extract with water and boiled with concentrated nitric acid. Next we have to boiled with concentrated nitric acid and added ammonium molybdate solution. Hot ammonium molybdate solution. Okay. Hot solution added. Hot solution of ammonium molybdate. The reaction will be like this. First, with oxidizing agent, sodium phosphate will be obtained. With nitric acid, it gets converted into hydrogen phosphate 3NaNO3. Okay. Now, next we are adding ammonium molybdate solution. Okay. H3PO4. NH4 twice ammonium molybdate. Okay. So what will happen is this gets converted into ammonium phosphomolybdate, which is yellow in color or yellow precipitate. This shows the presence of phosphorus. Okay. Compound obtained will be NH4 thrice PO4 12 molybdate, okay, plus 21 NH4 . This compound is ammonium ammonium phosphomolybdate. This is ammonium phosphomolybdate. This is yellow in color. This shows the presence of phosphorus.